Hi dear students, I hope you all are keeping well. Welcome back to the lesson for continuity and its consequences. We will begin the lesson with its learning objectives. The first one is to use the continuity property to study the continuity of a function or composition of functions at a given point, and then to use the intermediate value theorem to determine the zeros of a function. Now we will we will learn about both of this in the coming problems. We will quickly go through the keywords, that is removable discontinuity, non-removable discontinuity, intermediate value theorem, and method of bisection. We have a problem of this, and all this we will come right now. We will see both of these first two keywords now in this slide. So let's look at these four figures. So you can read through this. It tells about, how a machine is continuous and all that. But they give another analogy, like an explanation. A continuous function is something that can be drawn without lifting the pen. Something like this is continuous. Whereas now there is a hole over here. That means you will have to stop, remove the pen, draw a hole, and then you have to continue. So this is discontinuous or non-continuous. Now, I remember one of my students asking me, he was just drawing it. So I can draw a hole without lifting the pen or pencil. So this is continuous. But that's not the case. A continuous is having a break in the function. There is a problem or like a disturbance in the function. So this is, non-continuous. Now, how can we understand, what is the problems in the function? If you look at this graph, see there's a hole over here and it's not defined at this point because over here it would be undefined. So what we do is we use limit x as it goes to this particular point A, f of a, we find it out, right? So that means it's not at this point, it's near to these points. We have seen this in the last videos. So if you're getting confused in this, please go back to those videos, be thorough with them, and then come to this video. So that's about the hole. Over here you can see there's a jump. You can see there's a jump, right? So what happens over here is there are two different values because it's jump, discontinuity. Now here you can see it seems like this hole, right? See, but the limit f of a exists and f of a is defined, but they're not the same thing. See, f of a, why the limit exists, by the way, over here? The limit exists because you can see the left side and the right side are almost closing in on the same value or to this value itself, right? Imagine this value was, say, value c. Okay, the limit is c over here. The answer would be c. It exists because both one-sided limits, that is minus and plus, are coming to the same point. But f of a is defined as something else. Can you see over here? It's defined as something else. So these both are not the same. This limit over here and the actual value are not the same. So this is a whole, but still it's not the same. So therefore it is not continuous. And lastly, you can see over here, it just goes up to infinity. So limit does not exist. Now, one thing in the previous video, I remember I told if both the sides are going to infinity, we consider it infinity. Infinity means you don't have an exact value. Now, if it was, say, the limit over here, there was a hole, and this was, say, 4. Then I can say the limit of x, as it goes towards the x value of a, it is equal to 4. I can mention because it's an exact value. But when it's infinity, it does not exist, basically. But we just write it. If both are positive infinity, then we write positive infinity because we know it's converging towards, it's going upwards. Or if it's minus infinity, both are going downwards, something like that. Anyway, so these are all not continuous. Now we will see more about it. There's a definition, whatever we just now saw. If limit as x, approaches a for this function f of x is equal to f of a. So this must be true. Then it is continuous. See, if it is continuous for a, then whenever you substitute this a, there must exist. Okay. Say, for example, a polynomial function x squared plus 3x. Now you want to find the limit x of 2, okay? Then over here, what do? You substitute 2 over here, isn't it? 2 squared plus 3 times 2. Do you get an answer? Yes, it will be 4 plus 6, that is 10. You are getting an answer. That means f of 2 exists is equal to 10. So this is continuous. You can tell this is continuous. But for the same thing, limit as x approaches 2, if we had a function x squared plus 3x divided by x minus 2, now what happens? The denominator is 0, it's undefined, so no, this is not continuous. Okay, that is the two different things. Now I hope you're understanding. So then what we write is, we write discontinuous. So if at all it is discontinuous at I mean, if this was not true, then it's obviously discontinuous at this point. That's it. Let's look into this problem. You'll understand much better. Now, determine where it is continuous. Look over here. We have a denominator, so it is not continuous all the times. So where it is continuous. So if you just equate this to 0, when you equate this to 0, sorry, entire term, x minus 1 equals 0. What is x value? X is equal to 1. So it is continuous everywhere other than this point. So it is continuous everywhere, but it is not equal to 1. That is the answer. That's it. See, now what they're trying to say is, so f is continuous for x not equal to 1, because only at 1 you can see there is a hole. Other all points it is continuous, because you can put any x value, let it be minus 1000, minus 790, or any value as x, you will get an answer. But if you put 1 in this case, only then you will not get an answer. So that's why it is continuous for x not equal to 1. Why? Because there is a hole at x is equal to 1. We just did it, right? When we equate this, we will get the answer. This is a hole. So f of x is continuous only for x not equal to 1. Everywhere else it is continuous. Now extend the function from the last example just now which we saw and make it continuous everywhere, defining it at a single point. Now basically you're trying to do a piecewise equation so that you can make it continuous everywhere. What does this mean? So now over here you are telling this function, right, this particular function is x cannot be equal to 1, but we know from the limit what is the value? X is equal to 1. See, this is defined at x is equal to 1. A means x is equal to 1. So you're defining it over here. Now what it means is over here, you can see over here. Now for limit as x approaches 1 for this function g of x, you can see, you can solve this by factorizing. By factoring you can solve this, right? But now this is all a long method, but I'll just tell you this much is very important, and I will tell you how you can directly solve it. So you have understood that there is a hole, and so x cannot be equal to 1. So this must be understood. So what is at x is equal to 1? We can directly write this answer. What's the limit that answer? How do you find it? So instead of all this thing, you can just take your calculator directly and solve it for both the sided limits. You can write directly x. So it's x squared, write the function as it is, plus 2x minus 3 divided by x minus 1. And now I will calculate x to be, so since x is equal to 1, I need two values. One should be less than 1, one should be just more than 1. I will calculate this to be 0.99. And what is the answer? 3.99. Now I need to calculate it to be 1.01. And what is the answer? 4.00. So I know that is the answer, right? So now the piecewise equation, the answer would be, this is fine. We know already, we have solved it. X squared plus 2x minus 3 divided by x minus 1 if x is not equal to 1. But what is this a value? A equals 4 if x is equal to 1. You're defining this. So now it is continuous everywhere, because this is not continuous for 1, and if you consider the point 1, the answer is directly 4. So now that is what is done. You can solve it and you'll get the 4. So that is it. So now when g of 1, when you're considering this particular function at 1, what is the answer? It's 4. Okay, so that is the thing. So now over here in this case g is continuous, so we have found the limit. So that's the thing. And over here we have another function where we have two functions, f of x and g of x. F of x is 1 by x squared, g of x is cos 1 by x. Cannot be extended to a function that is continuous everywhere. So we need to show that these both cannot be extended. Okay, let's see them. See, this graphs won't be given, and you do not require graphs. Why? Because you can, directly do it in calculators. So, but if you see the graph of this, now anything divided by x is, it'll, as you increase this number, it becomes 0, right? But since it's x squared, now what happens is, as you're increasing, let's do it in calculator, okay? Because sometimes I just get confused in this. So 1 divided by alpha x squared. Type it as it is. Now, it can't be, over here now we are taking, because we have to show that it cannot be extended to be continuous every way. What should not be the denominator? Denominator must not be 0, isn't it? That's the only thing. If denominator is 0, this is undefined, because it's just going up and up. It's going towards infinity, both the sides. So what do? We take values near to 0. Take one value, negative 0.01, 0.01. Just plug it in. Now when you plug the values, calc 0.01, I'll take the negative first. What is the answer? You're getting 1000. You can just change this in this calc, negative 0.001. The answer keeps on changing. So it's infinity. You can't specify. Now in this case, in the previous problem, we knew that the answer would be 4. It's not changing all the time. But here you cannot, because it keeps on changing. As you go closer, as you just keep on changing the value from, say, big number, now I'm taking the right side, it just keeps on changing. The answer becomes millions, trillions, and so much more. So now, basically the limit does not exist because it's going to infinity, right? So, therefore, no matter what, you cannot consider this to be continuous at 0. So this will never be continuous at 0. That's what it means. And even the second one, if you're looking carefully, let's do it in calculator, because this graphs are for your understanding. Sometimes they might be giving it to you in your exams, but there's no way you can graph this. It will take you forever. So directly use the calculator. Cos. So it's cos 1 by x, that is over here. And close the bracket. Now make sure you change this to radian, otherwise you won't get the correct answer. It is shift mode. Let me just, okay, anyways, I'll write it again. I'll show how to change it to radian properly. Alpha x, close the bracket, press shift and mode, it will go to radian. You can choose the radian symbol when you press 4. See, now it's in radian. The mode is in radian. Now, all the time the denominator cannot be equal to 0. So over here, what's the denominator? It's just x. So basically, how do you do is, whatever is the denominator, make it equal to 0. Over here, x is equal to 0. If at all it was x minus 3, then make this equal to 0. It would be x is equal to 3. Here you should have put numbers close to 3. Now in this case, there is no other term, so it's only x. So x is equal to 0, take values close to 0, negative 0.01, positive 0.01. Now I'll type this, calc negative 0.01. What is the answer? It's 0.86. But now let me just check this. Negative 0.001, now it's changed. Same thing, let me go to positive side. It's just varying. You can see over here it's oscillating, right? It keeps on changing. You won't get a definite answer. Let's try again. 0.0000, big numbers. See, it's changing. I got 0.99, 0. So many different answers. So am I zeroing in at a single value? Like, am I getting just a particular value? Because in the last problem we had one single value. But in this case, no, it's not a single value. It's oscillating and you're just getting different answers. So basically, what is the thing? you are not able to make this continuous everywhere. So even if you do a piecewise, if you write a piecewise equation, no, at 0 it is never continuous. Okay, so that is what it means. So that's the thing. And now we have some theorems. So you can read this through, but I want to emphasize on the first one. We will be using it in the problems. See, the first one, it says, if you have a function, what's the consequence about continuity? If you have any polynomials, say it is x cubed plus 3x and everything, nothing divided by, it's always continuous everywhere. If it's sine, cos, and tan inverse, also it's continuous everywhere. So what this means is, you do not need to use the limit and everything. When you look at the problem, you can directly substitute whatever x is approaching the value, and then you will get the answer. It is continuous everywhere. So if they're asking whether it's continuous or no, if you look at a polynomial function, yes, it's continuous. If you look at these trigonometry, yes, they're continuous. Now if you have root of n, but if this radical n is odd, say for example it's 1, 3, 5, 7, then it's continuous everywhere for odd numbers. But for even numbers, it's only continuous when it's greater than or equal to 0. Why is that? Because let's see, we have over here cube root. So let me take a odd 3. Can I put any number? 45? Yes, I'm getting answer. What about negative number? Yes, absolutely. You can put literally any x value and you will get an answer for odd n over here radicals, okay? But now let me change it to 2. First, let me try this for positive number. Yes, you will get an answer, but let me take this negative. No, it is not possible, because inside a square root you can never have a negative symbol. That's not true, because it's an imaginary number over there, right? So that's why whenever it is even, it is continuous only when whatever the x value, whatever is there inside the root symbol is greater than equal to 0. Sorry, not equal to, it's only greater than 0. Same way with natural logarithm x, it should be greater than 0. And lastly, we have sine inverse or cos inverse x. Now this over here is continuous from x greater than -1 but less than 1. So these are the things the theorem 4.1 says, and this is very crucial because when you're solving problems, you need to know this. Now let's look at this and let's solve. Now determine whether it's continuous. So over here you can see there is a denominator, right? So be very careful, because there's a denominator, you need to equate this to 0 and you need to solve them, because there are 2 points. See, the graph might mislead. There are not only one, there are 2 points where you will have hole. So generally a computer generated graph may not give you the exact hole, so you need to find this, you need to solve this, equate this to 0 and find when the denominator will be equal to 0. The numerator is continuous, the denominator is continuous, but since you have something in the denominator, this can never be 0, right? So you're just equating this term to 0 and solve. How do you solve quadratics? You can solve by finding the two multiples and everything, but you can use a shortcut method by calculator, mod phi, and then to take the option 3. So what is the coefficient before x squared? There is nothing, that means it's 1. Then there is -3 before x. It must be x squared, x, and lastly it's the constant number. You have to write it entirely -4. And the answer is 4 and -1. So it gives you the answer x equals -1, x equals 4. So if you do by factoring, you will get 2 factors and you have to take the x to the values to the other side. But remember, these are the 2 values of x where the denominator becomes 0. So these 2 must be avoided. Okay? So what is the answer? Look. X should not be equal to 1, -1, and x should not be equal to 4. Then everywhere it is continuous. That's it. Why? Because they are polynomials. Polynomials are continuous. That's it. So this is the answer. So whatever is the denominator, equate it to 0 and solve it. You will get the answer. Now let's look into theorems. Again, now, okay, this is also again a simple theorem. It just says about continuity. If you have two functions, say if there are two functions, now if both the functions are continuous, then it is continuous. Now we will see a problem, and yeah, this is you can, you know, the composition of two continuous function is also continuous at that particular point. You can go through them. We will solve them directly. Now let's look over here. If you recall theorem 4.1, we know cos is continuous and polynomial is continuous. Okay, but they're composed together. Sorry. Can you see this? There are two functions over here, f of g of x. So these two functions, but f of x and g of x, because cos and this x squared minus 5x are continuous, isn't it? So the entire thing is continuous. Okay. Why? Because from the corollary of the theorem 1, which we just now saw, it says if two continuous functions are composed, then the entire thing is continuous. Okay, so it's continuous for all the values. And that's it. So since both are continuous for all x and h, it's continuous for all x. So you can have any x value. You can try this. You can choose any x value and put it over here, and you will get some answer. Okay, so that means it's continuous. That means you can just keep on drawing the graph. You will have an answer for each and every point for every x value. Now there are a few more definitions over here. It is about continuity in the closed interval. Now we will, if it is continuous, okay, so now what it says is, if any function is continuous from negative infinity to positive infinity, then it's continuous everywhere, directly continuous. But sometimes it may not be continuous, but you have been given a closed interval, then it is only continuous at that particular interval. Okay, so at that particular interval it will be continuous. Let's see a problem now. See, like this, we don't know about the other things this much. It is continuous. And sorry for that, the figure. Okay, let's look into this problem. Now again, we must recall which the theorem 4.1, where we saw the table, right? For square root 4 minus x square, all you need to do is whatever is inside the radical symbol, this root must be greater than 0. So then it will be continuous. So equate it. Now if you're thinking why I'm doing this, we can go back. Let me just quickly go to the 4.1. See over here. It is, if it is nothing, it's power 2. So it is even. For even, x must be greater than 0. So that's why I'm doing whatever is inside this must be greater than 0. I hope it's clear. So all we have to do is make it equal to 0. Say this one, this is the step. And now solve it. Now we take it to the other side. 4 must be greater than x squared. X must be... okay, now since it's greater than, we need to solve it by check. So it's plus or minus 2 greater than x. Okay, so now over here you need to test value inside the square root. Put, okay, it's minus, see, like this. Okay, there is minus 2 we found and 2 we found, right? We got the two values. Now how do we write x? So take a test value of minus 3, take a value over here 0, and take a value 3 and put it over here. So when we take minus 3, it will be 4 minus 3 the whole square is 9. The answer is minus 5. Can this be true? Can you have any values less than minus 2? No. Why? Because you're going to get a negative answer. So this will be wrong. This will be false. So your answers must be only x must be greater than minus 2. But what about again more than 2? If you take 3, it will be the same thing. It will be, if you put 3 square, it will be 9. 4 minus 9 will be wrong again. So it must be less than 2. Okay, so this is the limit we are going to get. So that is it. That's the interval. So now the closed interval is, what is the closed interval? Anything from minus, okay, you can also have this value. So we are writing closed interval minus 2 and 2. Why? Because it's continuous on this particular interval, not anywhere else. From the graph we can see anything within this range, you will get an answer. So it is only continuous from here until over here, not anything else. It's not continuous less than -2 and not greater than 2. So the closed interval will be -2 and 2. And from this we found out the -2 and 2, and then we are writing it continuous. Okay, continuous on the closed interval. So much. For this is a root problem, but the radical is even. If nothing is there, it's 2. That's why it is greater than 0. So this is the thing for this problem. And now we here again, it's a simple problem. Natural logarithm. If you go back to the table, you will know natural logarithm means x must be greater than 0. So x over here is x minus 3. It must be greater than 0. X must be greater than 3. That's it. So the answer will be, sorry, x must be greater than 3. Okay, now if you're writing an interval, what is greater than 3 means? 3 to infinity, okay? So this is the answer. It can be 3, 4, 5, 6 until any number. It should be just greater than 3 because you can't have anything less than 3. You will get undefined answer. So this is the answer for this. It's very simple, very easy. If you understand the concept, if you are thorough with the previous 3 lessons, then this will be very, very easy. Okay, as I told, easy. There's a little bit complicated problem. I mean, it's not complicated. It's also easy, but you can put it as interesting problem. Okay, a real world problem. So this is about internal revenue services. Okay, all these are very you have plenty of equations in this. Now the first few lines of the recent tax rate schedule for single taxpayers look like this. This is the table, and then you can get the function from this table. Okay, they have done one set of table and one function, and they have asked you to verify the federal tax is continuous. Now look over here. What it's saying is, wherever the taxable amount is over 0 and less than $6,000, your tax liability is 10%. Now, before I continue, we are very lucky and blessed to be in UAE because we don't have any taxes to pay. So, but in most of the countries, anywhere else other than the Gulf countries, you have taxes, and taxes are plenty, you know. It depends on how much you earn and everything. So over here, there'll be a range. If you earn so much to so much, then you will have to pay so much tax. If your earnings is more than this, so much tax must be given. So this is the calculation of that tax. Okay, so since it's in dollars, it's relating to US. So let's just understand how it is. And now, from 0 to $6,000, the tax is basically 10%. Your tax liability is 10 minus this number. Okay, minus 0. Okay, so what do you do is, whatever is, how do we write percentages? It's 0.1, 0.15 and 0.27. If you're getting confused, take out your calculator. There is the option over there. If you have 10%, shift and this symbol is percent, press equal to, you will get it. Or just divide by 100%. What does this mean? It means per cent. Cent means 100. So whatever number is before it, 10 per means divided by cent 100. So that will be 0.1. That's a little bit. So here you get 0.1, 0.15, 0.27x. I hope this much is clear how we get these piecewise equations. And now what is this? Minus, you are just minus 0. Since it's 0, we don't write it. Minus 300 minus 3,654. Now what is the range for these? So if the dollars is from 0 to 6,000, over, it should be more than 0 but less than, not over. It can be great, less than or equal to, it can be up till 6,000 but not more than that. It can't be 6,001. So this is the range. From 0 to 6, less than or equal to 6,000, you get 0.10x tax rate. Now, if it is greater than 6,000, that means it should be x is greater than 6,000, 6,001, 2, 3, and so on, but less than or equal to 27,950. This is the range. 0.15 x minus 300. And lastly, 0.27 minus this much will be for 27,950 to 67,700. Now this much is done for you, but what is the next one? It is over here, the table continues. If your taxes are from 6,770, like, sorry, 67,700, x is greater than that but less than or equal to 141,000. Okay, this should be in dollars itself. I'm sorry. Okay, but if you can just translate it, I mean, there's an error in this question. Half of it is given in this and the continuation is given in other currency. You can just consider all in AED or all in dollar, it's fine. Now 141, okay, this is the condition. If it's so much, what is the tax, what is the function? You can pause the video, take your time and try to write the function. I'll write it over here now. Because it's 30%, it will be 0.3x minus a. That is the function. You can keep on doing this for the other things, okay? Now over here they have asked you verify the federal tax rate T is continuous at the joint x is equal to 27,000. See, at this and this we must check whether it's continuous or no, and then find a and then find the value to complete the table. Okay, now for now they have just asked you to find whether it's continuous, and then you should find a value. If it is continuous, that means it's continuous throughout. Now what does continuous means? So this point, where is this point? This and this. So there are two equations. So limit as x approaches 27,950. But there are two equations. One equation is when it is less than, when it's minus, you need to use this equation 0.15x minus 300. But when you consider the same thing, limit as x approaches 27,950, but from the positive side, from the right side, that means it's greater, right? More than this, you need to consider the other equation, that is 0.27x minus 3654. Okay, there are two equations. Now what you need to do is basically find the one-sided limits. Use your calculator. We have done this in the previous problems and in the previous lessons. Just substitute this. This is a polynomial equation. I know this is continuous everywhere. So all I need to do is substitute this value and both the answers must be same, and then you can continue with the next part. Let me just do it. So you have 0.15 multiplied by x value is 27,950 minus 300, and the answer is, okay, let me write it, 3892.5. Now all you need to do is change this equation to the next one, that is 0.27. X value will remain the same, don't change it. It is 3654. And what is the answer? It is the exact same, and I can tell both the one-sided limits. The one-sided limits are minus and plus. Both these one-sided limits are equal, isn't it? They both are equal. You can see we found it. They both are equal, and hence this is continuous. So that is the first part. We have just verified it's continuous. Now we will get to the more interesting part. So that is the first part of the problem. Next would be finding this a value. Now we know everywhere it's continuous, isn't it? We have done this function, this, everywhere it's continuous. Now you have a. So what do you do? So let us consider, see, we have already an equation for this, right? Let us consider this particular x value, because this x value is over here and over here, isn't it? So we can use these two functions and find this a. What I mean is, let us consider the limit as x approaches. Let me just okay, sorry, limit as x approaches what? 67,000. I'll write 67.7. okay, it's k, okay, it's 1000. I hope you understand. Okay, this much. The function over here is, so from minus, one-sided limit from the left side would be 0.27x minus 3654. What about the right side limit? Limit as x approaches 67.7k plus. From the positive side, the function would be over here 30% means 0.3x minus a. Now this is the function, but we know something. What do we know? When we substitute this x value, both must be equal, isn't it? So now what it means is, I'll just write it over here. So it means that 0.27 multiplied by x value is 67,700 minus 3654 must be equal to what? I'll write it down. Must be equal to, it should be equal to 0.3. X value is 67,700 minus a. So if I just equate so much, I can find the a value. I can just put in the calculator, or I can take a to the other side, solve this, bring it to the other side and solve it up. Now for simplicity's sake, I'll just do it. 27 multiplied by 67700 minus 3654 must be equal to 0.3 into 67700 minus, we don't know a value, so we will write unknown value. Shift and solve. What is the answer you get? 5685. So this is the a value, and let's just check the answers now. See, this was the limit once both the one-sided limits were equal, and yes, we got the same answer. And so these both were continuous, and now to find a value, we just equate entire things and we solve it, and yes, we got the same answer, 5685. You can, if the textbook method is confusing, just now whatever I did the same thing. This concept is same, but it's just that they've written a lot of things, you know. You can just follow whatever I did just now and you got the a value. That's the answer. So that's it. That is a value. First we just checked for continuity, so that is over here in the first page. We just saw whether it was continuous. Yes, we got both the answers same. And we don't check it every time. We know it is continuous, so we just use this equation. See these two equations, 27x minus 3654, and the next equation from here, 0.3x minus a. And we equate those both at x is equal to 67,700. In both the sides must be equal, and you will get the answer 5685. That is how we solve this federal tax problem. It's a very taxing problem, and we are very lucky that we don't have taxes in UAE. So now let us continue. There's intermediate value theorem. We will come across this in the future as well, but in simple words, I'm not going to go in detail, but in just simple words, simple understanding, what it means. So you have a function like this, okay? At any closed interval, now you take an interval from here, it's a to b, okay? B is over here. From this interval, okay, if there is a value, say w is any number, okay, this is that there exists w over here, the value of this is w, you can see, okay, there is w in between them, then there will be a function which there will be a point in between a and b. It can be any point, we don't know, we are considering it to be c, that will be equal to w, because it's in between, right? It's between the closed interval. So it's obvious. So now in simple terms, like if I have numbers from 5 to 20, now there will be a number in between which will be the answer, which will give you the answer 15. It's kind of like that, you know, simple way to understand. The concepts are very much used in different parts, in different disciplines and stuff. Now we will see a problem. Now this is about continuity. It's the same thing. It's the same what we just now saw. Now over here, the last problem in this chapter, it's method of bisections. Now look at this problem and let's check your calculator. Can we solve this? Let's go to mode, phi, all the equations. See, mode and phi will give you equations, right? Mode, phi. Here you have power 1, 1, 2, 3. That's it. There's no 4, 5. How would you solve this? Okay, this is very crazy. Now, if they ask you this in the exam, it's going to take you a long time. I'm not sure this will, I mean, this might come, but the concept is, it's an easy problem, but it just takes a long time. That's the only thing, you know. They might ask you this with small iterations, you know. So let's say, how can you find this? Now, you know, other than graphing calculators, it's very hard to understand this, okay? But what do we do? So what we do is basically, we try to graph over here the basic things, okay? Okay, the graph is over here. Let's just I will explain this one by one. It's just the explanation. It's just a table, okay? All this explanation just tells you to get how to get this table. Okay, I will explain you this table. Don't think it's very crazy. Now this is a graph. Now what happens in this graph is you get an idea of where it lies. I guess the graph was given in this question, but even if it's not given, you can have an idea of a graph, or you can just try to plug in some values and find where the y value will be plus and minus, and therefore you can get any 2 points, okay? Now here in this graph, you get an idea. It's going up like this, and it's coming down, and it's going up, okay? Now we must focus on any point where the graph is up and down of the x-axis. That means, what is the y value over here? It is minus, it is plus, here it is minus. Okay, let's consider this point, easy point, 0 and 1. Now look closely. When x is 0, what is the y value? It might be 2 or 3. What is when 1, what is the y value? It's 2, it might be like minus 0.5 or something, okay? Minus 1.5, sorry. Okay, this is the y value. Now you got two y value, plus and minus y value. That means initially at one point at 0 it was up, now it's down. That means it passed through the x-axis, and this is the solution, right? That is one of the solution. So that's why we need it, plus and minus. We get a solution point. Same thing, the concept is the same. Now over here there are more accurate answers. So at 0, see, a is considered to be 0. Now we know if we take a closed limit from the intermediate value, there must exist a point which will be at a particular value, right? So basically intermediate value theorem is used over here, the concept of it. Now 0 and b value is 1. What is the value at x is equal to 0? It's not 2, I've written 2, it's 3, okay? The exact value is there. F of a is 3, this is 3. Now, what is at 1? It is not minus 1.5, mine way, not correct. It's 1, okay? This is the exact values. We are just looking and observing, so I wrote a bit wrong. It's minus 1. When x is equal to 1, the value, y value or f of b value would be minus 1, okay, because it's down. Say this is minus 1. Now where is the midpoint? Midpoint is over here somewhere, right? 0.5. We need to find what is the midpoint. Now if you're thinking how to find these accurate values, don't worry, you can use the calculator. I should have told that before. Mode 1, just take any of this value, say 0.1, right? Or even 0, substitute everywhere 0 and you will get answer is 3. Put everywhere 1, you will get the answer minus 1. Now I need to find at midpoint what is the value, plus or minus. So instead of x, I put 0.5 everywhere and solve. Plus 4 into 0.5 square minus 9 into 0.5 plus 3. Now what is the answer? 0.469. It's rounded off to 3 decimal points. So this is the answer. It's minus, right? If it is minus, now this is over. The first table iteration is done. Whatever is the answer minus, that will come over here, minus. If it was plus, it would have gone over here. That's it. Now you're writing this here and 0.5. This is function of b, right? Below this. Now function of b means b will be 0.5. Now you're solving it again. For this will remain same. A will remain 0, 3. This will be over here. Okay, fine. Now take the midpoint of 0.5 and 0 over here. Midpoint of these both basically. Midpoint of 0 and 1 was half. Now 0 and half is 0.25. So the value will be 0.25. Now here, the same calculation, instead of 0.5, you have to make 0.25 everywhere. The x value is 0.25. And now press equal to, you will get 1.001. Now what you need to do, this is positive, so it goes over here below the f of a positive sign. So you get here a value as 0.25. Now what is the midpoint of these both? It is not it's average only, but it's not always 0. Now over here it's 0.25, so you need to do 0.25 plus 0.5 divided by 2, and the answer is 0.375. Now put the 0.375 instead of x and you will get this answer, 0.195. So basically you don't need this graph. You can just, with these points, you can start and continue doing it. So now over here again you got positive, so instead of this value you change this over here. Now, and this value goes over here. The other two values will remain same. You just bring it down. Now solve for these both. What is the midpoint of these both? It is 0.4375. Put it over here and you'll get it, and it's negative, so this will come over here negative, and it continues. The loop keeps on changing. So this is how we solve this problem. And how much will you go? You can go until infinity. Okay, basically infinity will give you the exact correct answer, but you don't have much time over here. About 9 are done, but you know this process was continued 20 more steps and leads to approximate 0 of x is equal to 0.408922 and so on. So you find the exact value of x. This x is where the solution is at x is equal to 0.4089. So this is the answer for this. Now same thing can be done over here, and you will get the other answers, and that's going to take hours together. So I will stop for now, and you can try the other parts, but you know, if you understand the concept, it's more than enough, because this just keeps on going. You know, to find this you have to make the table and keep on going. So it's just crazy long. If you have options, now if you have many options, you can just plug the options over here and get the answer as well. So that would be the best thing. Now I will tell you, if you have 4 options, substitute the x value. Now we know the most accurate answer is so much, right? Now if you put that over here, 0.4089, that's enough. It's going to be to the power 5 plus 4 into x is again the same value, 0.4089 square minus 9 into 0, that's 0.4089 plus 3. Now when I press equal to, it must be, y value must be very close to 0. Let's see. Yes, it is almost 0, right? It's 0.000127 and so on. As I increase these digits, I'll get a more 0 number. So because it's approximation, you will never get exactly 0. So you can just look into the 4 options, and whichever gives you more accurate answer to, very close answer to 0, would mean whenever it's like 0.000 like this, it's almost close to 0, right? See, you can see. So that would be the more accurate answer. So this is one shortcut if you have the options. If you don't have the options, then you have to do this table. So this is how you solve this problem. And that's the end. I know it was a lengthy lesson, but it's, you know, it's easy if you know the other lessons. So please watch all these lessons, learn all these lessons in continuity, and then it'll be much easier. So that's it for now. I hope you have found this useful. Take care, guys, and please do stay tuned for the next video.